Good morning, students. Today I am going to deliver a short lecture on double refraction. What is double refraction in electromagnetic theory? For plain, double refraction means two refractions. Whenever a unpolarized light passes from a glass or another water, we see that it is being refracted. This is the single refraction. But in uniaxial crystals or just like calcite, etc., we see that whenever a ray of light or unpolarized light goes, what happens? It is incident on the surface of an isotropic crystal of calcite or quartz, then it is found that it is being separated into two rays. One is E ray, another is O ray. O ray stands for ordinary rays, E stands for extraordinary rays. These two rays have different properties. Ordinary rays are the faster rays and the extraordinary rays are the slower. These both ordinary ray and extraordinary rays are linearly polarized in mutually perpendicular directions. These are perpendicular, so obviously they will go in different directions. So there will be double refraction. Now I tell you about a ray of light incident on the face AB of a crystal travels along principal section and splits into two rays, namely O rays and E rays. The O ray travels through the crystal without deviation, whereas the extraordinary ray is refracted at some angle. As the opposite faces of the crystal are parallel, so the rays emerge parallel to the incident ray. Both E ray as well as O ray emerge parallel to the incident ray. As the velocities of E ray and O rays are different in the crystal, the refractive indices of the crystal corresponding to O ray and E ray will also be different. So we can find out this difference in the refractive indices as the amount of double refraction. So this amount of double refraction is represented by delta mu, and it is equal to mu E minus mu O. Mu E means extra refractive index corresponding to the extraordinary ray minus refractive index corresponding to the ordinary ray, and this gives us the double refraction, amount of the double refraction, or it is also known as birefringence. Birefringence. Now I will tell you about what Huygen told about this. Huygen's explanation of this double refraction. In order to explain the double refraction exhibited by the anisotropic crystals, and mostly the uniaxial crystals exhibit this type of phenomenon, Huygen postulated that the incident light excites two separate wavelets within the crystal, one spherical wavelet associated with the ordinary waves and one ellipsoid wavelet associated with the extraordinary waves. So according to Huygen's theory, there are different points which I can enumerate. Number one, a point source of monochromatic light in a double refracting medium is the origin of the two wavefronts or wave surfaces. Number two, the ordinary wave travels with the same velocity in all directions, and hence the corresponding wavefront or wave surface is spherical. However, in the case of extraordinary waves, their velocity varies with its direction, and therefore the corresponding wavelength is ellipsoid. That is not a sphere, that is ellipsoid. The so in this way, Huygen explained the double refraction. The optic axis defined in this way is the direction along which both O rays and E rays has the same velocity. So the two waves touch each other at the 2 points. So we can now, on the basis of this, we can also define the anisotropic crystals, and on the basis of double refraction, we can also define positive crystals and negative crystals. Positive crystals are those in which the ellipsoid is inside the sphere, and in the negative crystals the ellipsoid is outside the sphere, outside the spheres. And we can also say the negative crystals have mu e greater less than mu naught, mu e or mu of the extraordinary ray less than the mu of the ordinary ray. And similarly for positive crystals, the vice versa, opposite of it, that is mu e is greater than mu o. Thus, thank you friends, I simply explained what is double refraction, and in this way I also told you about I also told you about the polarization through the double refraction, we can also say, because after the double refraction, when the two rays come parallel to each other to the incident ray, they, if we can be able to eliminate either of them, O ray or E ray, then it becomes plane polarized. So we can produce the polarization. It is also called the production of polarization by double refraction. So this is the use of also of the double refraction. Thank you very much.